Curve sketching. It's putting your function, your derivatives together, and being able to sketch what you know about the curve based on increasing, decreasing, mins and maxes, concavity, so on and so forth. Okay? Let's look at example 1. Complete the table below by sketching the general shape of the curve when each condition is met. Now, let's talk about this. What does second derivative greater than 0 mean?
Concave up.
I hate those.
I know, it makes me laugh. Your hate for it makes me laugh. So.
I always write in if it's positive or negative.
And that's fine. You have gotten plenty warning that what is calc going to expect and use? They're going to use this. They're not going to say this is negative, this is positive. Now, what does first derivative greater than 0 mean? Increasing. So what does a piece of curve look like that is concave up and increasing? It looks something like that. I know. I'm laughing because Augie drew it in the air and Kate followed. Like you guys are all just drawing in the air. Okay. What does f prime of x less than 0 mean?
Decreasing.
It means decreasing. It means a negative derivative, so decreasing. So what's decreasing and concave up mean?
The other way of that.
Can we agree they're concave up and doing the increasing or decreasing, right? Okay, bottom row is going to be second derivative less than 0, so concave down. Can you visualize? Concave down and increasing.
Like this.
There's my version.
Yep.
And concave down and decreasing. The other way, yeah. It's kind of really the other half if you think about putting it together.
Yeah.
So, okay, guys. Being able to, those are pieces. As we go to sketch a curve, you have to be able to put together, okay, on this interval, it's increasing and concave up, or whatever, putting those pieces together. Okay, so example 2. Sketch a possible graph. Notice it says possible graph. Are all the graphs going to have to look exactly the same to meet the criteria? No. So sketch a possible graph that satisfies these conditions. Your favorite, g prime of x greater than 0 on negative infinity and negative 1 and 3 to infinity. G prime of x less than 0 on negative 1 to 3. Okay, so that's their fancy code speak.
We are.
And you know what? I need more space here. I'm going to zoom this in. Okay. So what's g prime of x greater than 0 mean?
Decreasing.
It's first derivative, so it's saying first derivative is positive, and when the first derivative is positive, my graph is going to be increasing. Okay? On this piece, g prime of x is less than 0.
Decreasing.
That's saying it's a negative first derivative, and so on this interval, my graph will be decreasing. Okay? Point 2. G double prime of x is greater than 0. Okay, that's saying the second derivative is positive, and when it's positive, we know concave up. G double prime of x is less than 0. Negative second derivative means concave down. Are we okay with deciphering those riddles? Your words, not mine. But I mean, I understand.
Yeah.
It is. It's breaking out the riddle code. Now, 3. This is different.
Why?
The limit as x approaches negative infinity is equal to negative 4. The limit as x approaches positive infinity is positive 4.
So it's like one of those.
Is it an asymptote?
Well,
That's what I was thinking.
think horizontal asymptotes is what they're giving code for here.
Oh.
So when we talk, and here's what, it's a weird thing. I don't know how it legitimately happens in an equation, but basically, as x approaches negative infinity, that's end behavior off in Mr. Arnold's room. Okay? So as you go to Mr. Arnold's room, the graph is going to run along -4. So that's saying there's a horizontal asymptote at y equals -4 on the left side of the graph. Okay? As we go to the testing room, this is Fernung's room over here. As x approaches positive infinity, it's approaching 4. So that's saying that over on this side, there's going to be a horizontal asymptote, but at y equals 4. So it's just saying the graph is not going infinitely up, it's going to approach that area.
Yeah.
Okay. So, let's see, a couple of things. If we start putting numbers on here, what? -3 to 3? I'm going to put 1, 2, 3, -1, -2, and -3. Those are kind of the minimum amount of x values you need. And in terms of y values, I'm going to have to go up to 4 and down to -4, right?
Yeah.
Now, the other thing I can do here, and I don't know, you may be able to start graphing this, okay? But the other thing I can do is kind of help you set up some like sign chart number lines. So if we think about the first derivative, okay? The first derivative, we had key points at -1 and at 3, yes?
Yeah.
And what do we know? From -infinity to -1, my graph was increasing. From -1 to 3, my graph is decreasing. From 3 to infinity, my graph is increasing. What are we setting ourselves up to know? Mins and maxes. At -1, there is a max. At 3, there is a min. Okay? And I'm not saying, do you have to do these charts to succeed at this problem? I'm not saying you have to. We're beginners. And I can easily get myself confused if I'm not careful. So, now, let's also talk about the second derivative at these same place values. Now, although in second derivative, what? We had 3, we had -1, and I also need to throw in -3 over here. Okay? Now, notice, I did line up my -1 and 3 on purpose with the sign chart above. Okay, what do we know? From -3 to -3,
We are.
concave up.
Yeah.
Oh.
-3 to -1, concave down. -1 to 3, concave up. 3 to infinity, concave down. So all of those places also just became POIs, points of inflection. Okay. Okay.
Oh, wait. I can't imagine.
Are we struggling to figure out how this is even going to?
Sure. Okay, it starts like this at the 4.
Okay. And one other thing I can draw on here. It was horizontal asymptotes, yes? So as x approaches negative infinity, it's -4. So basically on the left side of the graph, there's a horizontal asymptote at -4. It's not going to necessarily go all the way. I mean, I guess you could think of it as all the way across, but it's not going to matter on the right, because on the right, what did they say? My graph is going to be approaching +4. Okay? Okay. So,
There's max and
Yes.
there's just like there's -3. I think I see it. No,
I don't
yeah,
see
I
it.
do.
It's not really
Okay.
connecting for me.
okay. Now, and we don't have y values with any of this.
Wait, where's the?
Okay, got it.
I don't know. I'm backwards from you.
That's why that's.
Okay, so one thing, let's see. So my graph is starting off increasing and concave up, yes? So increasing and concave up.
Oh no! I missed
Now, at -3, there's going to be a point of inflection.
So that means it.
So it's going to change concavity. So it's going to go from increasing and concave up to still increasing but
Concave down.
concave down.
So
And we're going to have a max somewhere on the -1 line. I'm going to arbitrarily, well, okay. Do I just draw it in at this point?
yeah.
I mean, so we're increasing and concave up. As you cross over the -3 line, you're going to change and be still increasing but concave down. So let's see.
Wait, then what?
You end up pointing way.
And there's another one.
Kind of.
No, that's good.
Okay,
I don't want to look.
here's what I'm aiming for. I'm running along my horizontal asymptote, yes? In the 3, it can be anywhere vertically at -3.
There's a max.
There is a supposed inflection point. You see my inflection point-ish?
Yeah.
And I'm not saying you even have to put the dot, but there's an inflection point where we change from concave up to concave down, increasing the whole way. And then when we're above the -1, we have a max. Okay? Now, what are we doing between -1 and 3?
Go down.
We're decreasing
But
and we are
concave up.
concave up. So,
Oh wait, we have to.
like that, right? But hold on, I didn't put that. Yeah, I have to, let's see, how far do we go? We go to 3. And at 3, there's going to be a min, yes?
Yeah.
So, I don't know, something like that.
This is great.
Am I concave up and
Yeah.
decreasing?
Yeah.
Do all of our graphs look identical?
No.
Guaranteed no.
No, mine was crazy.
And it's all about, are you meeting all of the pieces? Now, it's a min. It's a point of inflection, but that's just because concavity changes. What are we doing to the right of 3?
Approaching 4.
Increasing
Increasing concave down.
and concave down.
But it's like.
Are you visualizing it?
Yeah. Bold. Who would ever want to graph this?
Okay. My concavity changed. I had a min,
Oh.
and I went up and I ended running along the horizontal asymptote of 4.
You're not leaving enough room.
Again, as long as you understand, not all of our graphs are going to look the same. It's about, did you meet all of the criteria? Okay? Did you make it concave, up, down, up, down? Did you get your mins and maxes? You know? Okay?
Those are kind of fun. I like graphing.
There's a lot to it. There is a lot to it. So, okay, moving on. This is curve sketching, right? We just sketched a curve based on the criteria they gave us. Okay, on the next page, they gave us this chart in the previous lesson. Okay, kind of your codes, positive, negative, increasing, decreasing, concave, up and down. You've seen me use those. Okay, and this is kind of your chart that connects them. Okay, if a second derivative is positive, first derivative is increasing, it's concave up. If the second derivative is negative, first derivative is decreasing, original is concave down. First derivatives are positive and negative, then original graph is increasing, decreasing. You've seen those charts, okay? Now, here's another type of curve sketching. They are giving us f prime. This is the derivative graph. Okay? They are asking us to sketch the original graph. And we're going to sketch it on the same axes. Okay? We're going to sketch this on the same axes. So the key is gathering the information from this graph right here to know enough to graph an example of f. Now, first of all, did I use, yeah, that's what I thought. In my notes, I referred to these 2 points as A and B, just because I want something to refer to them as. And I'm going to set up a sign chart for f prime, because I want to gather some information. Okay? So, this is the derivative graph. Key points here are going to be A and B. Now, this is the derivative. Before you get to A, what do we know about the derivative before A? I don't want to know that it's decreasing. I want to know when is my derivative positive, when is my derivative negative.
Negative from negative infinity. Wait.
Positive from negative to A.
Okay. In other words,
It's above.
I'm not asking, this is the derivative graph. I'm not asking about the derivative of this graph. That would be second derivative. I want to know, this is telling me about the derivative. Before I get to A, this graph is above the x-axis. If something is above the x-axis, it is positive. So this graph is positive before A, so that means my derivative is positive before A. Between A and B, my derivative will be negative because it's below the x-axis. And then to the right of B, my derivative is positive. Now, that's the derivative, yes? What does that tell me? So that's the derivative. What does that tell me? An increasing derivative tells me the original graph is going, did I say that? I think I said that wrong. A positive derivative tells me the f graph is going to be what? Increasing, right? A positive first derivative says this is going to be increasing. So when I draw f, I'm going to be increasing. A negative derivative says my graph is decreasing. And a positive derivative says my graph is increasing. So those are f. That's the graph I'm getting ready to draw. What's going to be happening at A?
Max.
If we go from increasing to decreasing, there's going to be a max. What's going to be happening at B? Because you're going from decreasing to increasing, there's going to be a min. Okay? So right there, does that, my graph's going to go up, down, up? Now, the other part, in all honesty, you can pretty much draw the graph there, is what I would say. The other piece we can consider is the second derivative. Now, okay, wrap your brains around this. The second derivative is the derivative of the first derivative, yes? Which means this graph is f prime. F double prime is the derivative of this graph. This is what you were trying to do earlier. So what do we know first? My derivative is what? It's negative because it's decreasing. My graph is decreasing, right? It's negative for how long? To 0, yes? Negative slope, negative slope, negative slope, negative slope, all the way to 0. And then what are we past 0?
Increase.
Positive slope, positive slope, positive slope, positive slope. Now, this is second derivative. What does a negative second derivative mean in the original graph? Concave down. And a positive second derivative means concave up. And then that means, I forgot to write in, this middle point is 0. At 0, there's going to be a point of inflection. Okay? Okay. We ready to graph? What do we know? Increasing?
Decreasing and concave down.
Decreasing? Increasing. So there's a max, arbitrary point. We don't know the height of that max, right? There's a max on the A line. There's a min on the B line. Again, arbitrary points. They have to be lined up with A and B, but I don't know their heights. I'm making that up as I go. Okay, we are increasing. No, what? Gosh. Okay, increasing, concave down.
Wait, and then it's like like that.
Is that.
Yes.
It doesn't necessarily have to go through 0, 0, I don't think.
Wait, doesn't it? Because that's a point of inflection.
Whoa.
Well, 0 is a point at x equals 0, but the y value does not necessarily have to be 0.
The y value doesn't matter.
Okay, unfortunately, I would have loved to have filled in 1 through 6 right now, but I so was unaware of the time.
Okay. I hit my funny bone.
You're funny bone or you're not so
Why'd
funny
you
bone?
turn Australian?
Not so funny.
That actually
Okay.
kept me way more awake